Okay, so let's take a look at an example where we calculate a double integral over a rectangular region. So the rectangular region we're given here is x goes between 0 and 2, and y goes between 1 and 4. Okay, so first let's set up our integral. So depending on whether you want to integrate with respect to x first or with respect to y first, so let's first set up as dx dy, right? So the outer integral will be y. So the outer integral goes from 1 to 4. The inner integral will be with respect to x, so that goes from 0 to 2. The function is 6x squared plus 4xy cubed. Again, the inner integral was x, so we write dx first, and then the outer integral was y, so then we write dy. But again, Fubini's theorem says that it can actually be written either way. So written it the other way, it will be 0 to 2, and then 1 to 4. The function is the same, so 6x squared plus 4xy cubed. Here the 1 to 4 is for y, and then the 0 to 2 was for x. Okay, so again, it can be calculated either way, but to save time, I'm only just going to calculate it the first way here. Okay, so the inner integral is calculated first, right? So let's make a note of that. Right, so this inner integral is a partial integral with respect to x. So we think of so as we calculate the inner integral, right? So this part stays unchanged. I'll give myself a little bit of extra space, so let's put the dy over here. That part's going to stay unchanged. Right, so now I calculate the antiderivative for this, right? Again, with respect to the variable x. So here I apply the power rule. So I increase the exponent by 1, divide by the exponent, so that's 3. And then here, the antiderivative of this, again, just with respect to the variable x. So the power of x goes up by 1. I'm thinking of y as being a constant, so this stays unchanged. And then I divide by the exponent for x, right? So that was 2. Okay, so that's the antiderivative, and it needs to be evaluated at the endpoints. So from 0 to 2. Okay, so now we have to evaluate this thing here. So again, this part stays the same, right? So I plug in the top number first, in for x, right? Because we're still working with the variable x. So the 2 goes in for x. The 2 goes in for x. And then minus. Now I plug in the bottom number in for x, right? 6 times 0 cubed over 3 plus 4 times 0 squared y cubed over 2. Okay, so luckily when you plug in 0 here, this is just 0, and then this makes also the whole thing 0. So this whole thing goes to 0. Okay, so now I just need to worry about this first part here, right? So 6 divided by 3. So I still have the outer integral. It's still sitting there. Okay, so now here let's calculate this. So 6 divided by 3 is 2, and then 2 cubed is 8. So 2 times 8 is 16. And then this 2 squared is 4. 4 times 4 is 16. 16 divided by 2 is 8. That's y cubed. And then this whole thing was 0, so that goes away. And then I still have my dy. Okay, so before we continue with the calculation, again, notice after this evaluation, so this completes the inner integral, right? So notice how this expression can still contain the variable y. However, now this outer integral is just a regular ordinary integral with a single variable. So we just calculate this as we do in Calc 1. Okay, so the antiderivative of this, the antiderivative of a constant is the constant times the variable, which in this case is y. And then here I do the power rule for integrals. So the power goes up by 1, divide by the exponent, and then I evaluate at the endpoints. Okay, so now we just calculate. So plug in the top number, 16 times 4 plus 8 times 4 to the 4th over 4 minus 16 times 1 plus, let's just simplify things. So 8 divided by 4 is 2, and 1 to the 4th. Okay, so what is this equal to? So 16 times 4 is 64. And then here 8 divided by 4 is 2. 4 to the 4th. What is that? 16 times 16 is 256. 256 times 2 is 512. And then minus 16. And then this minus also distributes to this, so that's minus 2. Okay, so what do we get in total? This is 576, 576, 566, 560. 560 minus 2 is 558. Okay, so so this is the value of this definite integral here. And again, so let's quickly review the process, right? So we first calculate the inner integral with respect to x, and that results in something that may contain the variable y. But then now we proceed to calculate the outer integral, which is an ordinary definite integral, and this results in just a single number. Okay, so that's how you calculate a double integral over a rectangle.